Hello, Year 8! So, you know about Newton's three laws of motion, you've just figured out how forces can cancel each other out. But now you're wondering, hang on, how do I know which force applies to which object, and which forces will cancel out? Well, that is what we will be going over today. So, let me ask you this question. Have you ever been waiting at train tracks and thought to yourself, hang on, if every action has an equal and opposite reaction, how the heck is this train moving at all? And for that matter, how does it even get this car moving? Or even walk to the car? A scary thought indeed, but you can be calm to the fact that yes, the train is moving, and yes, every action does have an equal and opposite reaction. But it's what those reaction forces are actually acting on that make movement possible. So, without further ado, let's get right into answering the question. If forces are equal and opposite, how can a train pull its carriages forward? But, before we go diving straight into that locomotional quandary, we need to look at a few key laws of motion. To begin, the second law states that an object will or will not accelerate due to the forces that act upon that object, or in mathematical terms, force is equal to mass times acceleration. That one's pretty simple. If you kick a soccer ball, it's going to move, and if no force is applied, no acceleration will occur. Now, this is the big one for our question. The third law states that every action has an equal and opposite reaction. However, when looking at questions about the third law like these, we have to avoid falling into the trap of misidentifying or missing the third law pairs. To show you what I mean, I'm going to show you an image with the missing third law pairs. In this drawing, we have the action and reaction force of the train and carriage cancelling each other out. Thus, no movement could ever occur. Now we know that this can't possibly be all of the forces present in this scenario, because, as I'm sure you all know, we use trains every day to ship resources and transport people all across the place. And it would be very hard to do this if trains didn't move. So, if this train has a net force allowing it to pull the carriage forward, I want you to take a few moments and think, what other forces are present here that are affecting the movement of the train and carriage? The answer is the action and reaction force of the train's wheels with the tracks. You might also have said that the drawing was missing the gravitational force. However, since the force will be cancelled out by the normal force on each object, we don't really have to worry about it for this question. If we draw in the previously missing force, we now see that the train is getting the extra push forward from the track to create a net forward movement. You might also be wondering, if the train is pushing on the tracks, shouldn't they also move back? And the answer is yes, they definitely would. However, Newton's second law, rearranged to give us acceleration is equal to force divided by mass, we can see that due to the immense mass of the track steadily secured to more track and fixed into the earth, the acceleration is going to be very small indeed. So, now all we have to do is set up the forces acting upon each object, focusing here on the train as it is the main source of movement. We do this to see what a net positive movement is. As you can see here, we have a force of 8 newtons from the carriage and a force of 10 newtons pushing the train forward from the ground. And that's it. We see here we have a net forward force of 2 newtons overall, meaning that the train will move forward. Off it goes. Now, how about a quick bonus question? This one, very similar question. The only difference is the forces applied from the carriage and the forces applied from the ground. I'll give you a few moments to figure it out. So, using the exact same process as before, we simply add the horizontal forces together, and we get an overall net force of 0 newtons, meaning this train is not moving anywhere. So that's it. Next time you're at that train crossing and you're thinking, how the heck is that train moving? It's got to do with which forces are acting on which objects, and whether those forces are balanced or not. Other than that, if you have any other questions or want some more clarification on something in the video, please don't hesitate to let me know. Until next time, thank you all for watching.